Hello everyone, wishing you all a very good morning. Good morning Tejasvi. Good morning Jasmine. Good morning to everyone. Charita, good morning. Ganesh, Srinath, no sorry, Sainath. Good morning beta. Vaini, good morning. How are you doing? I hope I am audible and visible to all of you. Someone is sending me. Thanks Tejasvi. Thanks for the wishes. Reddy, Yashwant, please send me message on the other ID beta. I can't see it on this ID. Jasmine, thanks for the uh, response that my audio and video is clear. Good morning, Hanak. I hope all of you are doing fine, healthy, happy. All must remain happy. I am fine. See, fine. I am never sad. Sometimes I get cough and cold, and sometimes I might not feel good. I am feeling okay. Just feeling a bit. Thanks, Ainath. Thanks for wishing me Teachers' Day. Thanks, beta. Good morning, Jogeshwar. Enough of pleasantries. Where was I? Yes, instructions of how we are going to conduct the class. Everyone knows it by now. Keep your cameras off so that you don't consume extra what you call data. Then if you have to send any message, send it on the ID of Astic, because the other ID is very difficult for me to see it on that, because everything goes here and there. My screen sharing stops and everything. I've got a complicated system over here. As I told you, I'm a simple guy with Pentium processor, way back, outdated. Somehow I have managed things on my own, and thanks, Ashwant. So please send me message here. It's easier for me to see it here. I can't just see it there. I touch this screen and things happen. Okay? I don't want that to happen. And see, I have a very small brain. I have always told you that. And if things happen, if things don't go according to my plan, my minds get distracted, and I just then it takes time for me to come back and teach you again. Okay, so my kids are playing. Okay, so what I was telling you. Okay, someone told me what we were doing in the first class, last class. Who was it? Vaini? Okay, we were doing Newton's first law. Yes, Newton's first law. We were doing. We were dealing with equilibrium. I told you the meaning of equilibrium. When the net force acting on a particle is zero, we say the particle is in equilibrium. If it is at rest, it will remain at rest. If it is moving with uniform velocity, it will continue its motion with uniform velocity. Property is known as inertia. This law is known as law of inertia, or Newton's first law of motion, or simply equilibrium. And we saw how we can solve problems based on that equilibrium. In today's class, we'll move ahead and see some more problems on this topic of equilibrium, because if there is a problem that comes in this particular chapter, there is a very good chance that it either comes from this equilibrium wala thing, or it comes from simple question on Newton law, or probably a more advanced one, it will come from friction. So there are only three main topics here. And I expect a question, if there is a question in JEE Main or Advanced, and it will come from any one of these. So we have to spend some time on that. And let us start today's class with a very simple question. In this question, we will try to find out the unknown quantities. Let's see how we do it, and which question should I start with? Okay, let me start with this one. Your DPP I have already given, so I think that DPP will be given to you in a day or two. So the DPP will be there. The DPP has a lot of questions in it, similar to what I am doing here. So this is a system that I have drawn. Oops. Okay. So in this system, what I have, should remove this, not looking good. Okay, in this system, what I have is I have three bodies. One mass is 6 kg, the other mass is 2 kg, the third mass is unknown. How many strings you see here? I think I can see three strings. This is string number 1. This is string number 2. And yes, Anna, this is string number 3. So there are, oh, the upper one, 3. So there are 3 strings. So obviously the system is in equilibrium, the net force is 0. You have to tell me what are the tension in the strings and the value of unknown quantity m. You have to give me the value of m, find the value of m, tension T in all the strings, and that's it. Tension T and m. That is what I am looking at. The time starts now. How are you going to do this? Start doing this. I'll tell you the steps one by one. I hope you have recollected them. I hope you are writing your notes. I think I have an answer for mass m. Mass m is 4 kgs. Yes, it is 4 kg, Yashwant. Well done. But the question is not over. You have to tell me all the tensions as well. The value of G has to be taken as 10 meter per second square. I hope you are making notes. I have not seen notes of anyone. I will find a way of seeing it. How many of you are making notes? Can you raise hands? How many of you have made notes up till now? Only 5 people have made notes. Not good. 8, 7, 8. Only 8 people are making notes. That is not good. If you are not making notes, I am sure that you will not do good in the long range. I am not a very big fan of giving you everything that you can just read. No one can clear JEE by reading. I have not seen anyone who cleared JEE by reading notes. No one. Not in this universe. So I guess, I hope, I request, I can't compel you to make notes. If you don't make notes, take it from me in writing, you will not be able to clear JEE. Finish. End of story. Shashank, Karthik, Srilata, 2111, Navya, Veronica, all are good students. 3001, 24, 20, 23, 30, 20, 30, 20. So many numbers. I just can't talk numbers. I don't like to address living beings with numbers. Surendra, Siddharth, Jashwant, Padmakant, Ganesh, Dinesh, Praveen, Karthik, Jogeshwar, Charita, Raju, Aishwarya, then some numbers. I don't want numbers. Sanjay, Rahul, I urge all of you, please, please, please make notes. If you don't make notes, don't blame me at the end of the day, or for that matter, the way we have taught you. So, here we are. I'll tell you the steps and then I'll start solving this problem. I think I've given you enough time to solve this problem. Has anyone solved it? Can anyone raise hand and tell me, sir, I have solved it, and I'll help you in solving it? Because if you don't help me, then I'll have to go solo. Ekla Chalo Re. I told you that famous poem by Sir Rabindranath Tagore. Ekla Chalo Re. The only line I know is Ekla Chalo Re. It means that you have to go alone if no one helps you. And that is how life is lived. Ekla Chalo Re. Anyone? I got some response. Sir, the answer for 1 is 60. Tension in string 1 is 60. That is correct. Well done. What about the other answers? Tension in string 2. Okay, let me start step by step on how to solve this question. Remember, step number 1, 2 is 40. 2 is 40, Yashwant. Correct. 2 is 40, 1 is 60. What about 3? 3 is 120. That is absolutely correct, Yashwant. Let me now solve this question step by step for all the others who are still trying. So the first step, if you remember correctly, was draw the sketch. Sketch is already there. Isolate all bodies. I don't need to isolate. They are all away from each other. So I assume that they are isolated. Because if I have to isolate them and draw their separate figures, it will take more time. And remember, I have always told you, whether it's JEE Main or in some extent JEE Advanced, there are more exams that test your speed and accuracy more than your knowledge. JEE Advanced to a certain extent tests your knowledge. JEE Mains is just testing your speed. So I don't want to lose on time, valuable time in drawing free body diagram separately because it will take a lot of time. So I'll draw it in the original sketch only. So isolate the bodies. I've isolated, draw free body diagram. To start drawing free body diagram, I will start with tension. I will start with tension in this string. Let me call this as T1 because this is string 1. Let me call this as T1. Pulling. This will be T1 and this will be T1. So this is tension in string T1. Now let us come to string T2. I don't have to call it T3 because I know this string is attached to a pulley. One force is upwards on the pulley, two forces downwards on the pulley. Pulley is massless, so upward force must be equal to downward force. Yes, Jashwant, the upper wala string ka tension would be 2 times T1. Do we all agree on this? Can I have some raised hand that we agree on this? Yes, sir, no problems with this one. T1 down, so it has to be 2 T1 up. Okay, now let us come to the string number 2. Now, if you can see, the tension in the upward string is T1. What about the tension in the lower string? It will not be T1 because there is a mass here. So I have to call it by a different name. Let me call it as T2. Now you will ask why I have drawn the tension downwards, because tension can only pull. So it is going to pull the block downwards, but the same tension will pull the block M upwards. Do we understand this? Okay, so now I have drawn all the tensions. Half of the tension is over for the exam. I mean, for the question. Let us draw the remaining part. For this 6 kg block, the only other force that is acting on it is gravity, which is 6G. G is 10, so it becomes 60. So this is the free body diagram of block 6 kg. Do we understand this? The free body diagram of block 6 kg, it is simply here. As soon as I draw this diagram, let us not waste any time and let us write the equation for this. Okay, let me do it stepwise, then I will do it the shortcut way. So I have drawn the free body diagram of 6 kg block. Now let us move on to this M. T2 is upwards, weight will be downwards, weight is mg, m is 10, m is m, g is 10. This is the free body diagram of the block M. Do we understand this? Let us now move on to the last block. And the last block happens to be this. T1 is upwards because it is a bit congested space there. T1 is upwards, T2 is downward. Is there any force that I'm missing here? Is there any force that I'm missing here? Yes, I'm missing one force, which is the weight of this block. And the weight of this block is 2 into G, which is 20. This becomes the free body diagram of block 2. If you are getting confused in this free body diagram of block 2, I will again draw it here. This is the block of mass 2 kg. Downward force, there is T2. Downward force, there is 20, which is 2G. Upward force, here it is T1. So I have drawn the free body diagram of all the bodies. Now I will have to assume some axis as x and y. Everything is vertical, so vertical axis becomes y axis, horizontal axis becomes x axis. There is no force on the horizontal axis. I don't have to draw horizontal axis. I don't have to write any forces. Let us write the equations for this block of 6 kg. There is no force on the horizontal. Upward force is T1, downward force is T2. Forces should balance. So what is the equation I get? T1 is equal to 60 Newton. Do we understand this, or have I gone too far? Can I have raised hand that we understand this, sir? Only 8 people have understood this? No, that is not good enough. Manasa, Praveen, Shashank, Shilata, Ishika. Then some numbers, I don't call numbers. Surendra, Siddharth, Satvika, Reddy, Padmakan, Ganesh, Jasmine, Dinesh, Karthik, Shashank, Charita, Aishwarya, Sanjay. Are you all there? Yes. So basically on the 6 kg block, T1 is acting upwards, 60 is acting downwards. Upward force must be equal to downward force because net force has to be 0. T1 should be equal to 60. Am I clear? Someone asked me to repeat it again. I missed the name. Who was he? TNK 3014. Okay. Now let us write the equation for this block. There is no force acting along the x-axis. Forces along y-axis must equate. T2 is upwards, 10m is downwards. So T2 must be equal to 10m. The problem is I don't know T2, I don't know 10m. So I can't solve this. But you don't have to worry because we are still left with one more block. This is the block that we are left with. Let us write the equation for this block. There is no force along x-axis. So don't be worried about the x-axis. There is only forces on the y-axis. What are the forces on the y-axis? T1 is upwards. T1 upward should be equal to what are the forces downwards? T2 plus 20. T1 is T2 plus 20. So from there I can get the value of T2. T1 is 60. So T2 becomes 40 newtons. Do we understand this? Yes or no? T2 becomes 40 newtons. T2 weighs 10 times M. So M becomes 4 kg. So these are the answers that I was looking for. This mass happens to be 4 kgs. This tension T1 happens to be 60. Looking good. This tension 2 times of T1. So it is 120. Do we all understand this? So it is going above our heads. Then this tension, I think I have marked all. No, I have not marked this tension. This tension is T2 and I am drawing the wrong arrow. Where is my mind? T2 is 10m and T2 here is 40 newtons. Do we understand this? How I have done this? I have not used any extravagant method. I have just followed step-by-step solution. Number 1, draw the sketch already there. Number 2, draw the FBD. Number 3, assume axis x and y, vertical and horizontal in this case. Number 4, draw all forces. Done. Number 5, equate all forces. Done. Number 6, get equations. Done. Number 7, solve equations. Done. Number 8, stay happy. We are happy. Will you be able to do the next problem which I give you? Yes, no. Some people have kept on raising their hands and then don't lower their hands, so they don't have to raise it again. So I will keep on lowering them. Are we ready for the next one? And the next one appears here. You must understand that whatever questions we had done during drawing that free body diagram, we had done those questions because same questions are going to appear while we are solving all. The questions are not independent, they are dependent on what we had done. So this is the system that I've drawn, similar to the diagram that I gave you to draw the FBD. What would be the question here? Obviously, we are supposed to know the unknowns. What are the unknowns? We see strings here. How many strings we see? If I am correct, this is string number 1. And this is string number 2. Probably 2 strings here. Okay. This is wall. So this string is also exerting force on the wall. So I can ask a variety of questions depending on how I ask you. What I'm asking is the value of mass m. Oh, I have very clear about colors. It must be in black. The value of mass m, the tension in all strings, the normal reaction from ground. This block will have normal reaction coming from ground. The normal reaction coming from ground, and the force on the wall. I'm very clear about color, so it must be black. The force on the wall. What will be the force on the wall? Anyone? This wall. What will be the force on this wall? Anyone? What will be the force on this wall? Draw your free body diagram. T. Yes, T. T will be the force on this wall. That is correct. T. Yes. Draw your free body diagram. And remember my words, golden words, beta. Once free body diagram is done, the question is solved. The time starts now. Follow the steps and give me the answer. Meanwhile, I'll have a sip of water. Follow the steps, simple steps. Once you do 2, 3, 4, 5 problems, those steps should come naturally. I'll give you a minute. I'll take myself off. I'll give you a minute. Okay, I'm having some answers. Let me have a look. T is 50, N is 50, M is 10 kg. Good. Someone has sent me answer here. I know that. Okay. Chalo, how you do this? We start with the sketches there. To draw the free body diagram, I start with tension. Let me call tension here as T. Tension here will be 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 T. Tension T. T. And T. Okay. Now, this is T. This is T. So, this will be 2T. This will be 2T. So, we are done. Now, let us start with the free body diagram of this block, small m. What is the free body diagram of this block? One force I have already drawn 2T. One force I have already drawn 2T. Then I will draw the next force, which is gravity, which is downwards. This is 10m. So this is the free body diagram of block mkg. Let us talk about the free body diagram of this block. One force is 50 Newton, already drawn. One force is T, already drawn. 50 is downwards. Normal reaction is upwards. This becomes the free body diagram of this block. Now I have to write the equation of this. I will assume y-axis like this. I'm not drawing it because I'll just draw it. This is my y-axis. This is my x-axis. There is no point of drawing the forces along x-axis because there is no force. The only equation will be along y-axis. What is upwards? 2t. What is downwards? 10m. So 2t becomes 10m. Do you all understand this? Can I have raised hand that you understand this, sir? 2t is equal to 10m. Okay. Now we go on to this block. In this block, as you can see, you'll have to draw the two axes. This is your y-axis and this is your x-axis. Do we see this? X-axis and y-axis. Because there are forces on vertical as well as there are forces along the horizontal. Both the forces should balance. Both the forces should balance. Let me write the forces along x-axis, the green one. See, on the right hand side I have T. On the left hand side I have 50 Newton. So what will I get from x-axis? From x-axis I will get T is equal to 50. Do we all understand this? The green one. Can I have raised hands for everyone? So we understand this. No problems with this one. Okay. Now, let us look for the y-axis value equation. For y-axis, see here, the blue one, the blue n is upwards and 50 is downwards. Do we see this all? Do we see this all? So now I write the equation for y-axis. I will just write it here. For y-axis, the equation looks like, what does the equation look like for y-axis? N is equal to 50 Newton. N is equal to 50 Newton. So now I have the answers for everyone. Mass M is the only unknown remaining. Mass M, how will I get the value of mass M? I know the value of T, I can put it here, and from this equation I can get the value of mass M. Yes or no? So what is T? T is 50. T is 50. So 2T becomes 100. 100 equals to 10M. My M becomes 10 kg. So here I have the value of mass is 10 kgs. The value of tension T I've already got is 50 newtons. Let me not write it this way. Not looking good. Tension T is 50 newtons. Normal reaction is also 50 newtons. What about the force on the wall? What about the force on the wall? What is the force on the wall, anyone? What is the force on the wall, anyone? As you can see, this is the wall and this is the force on the wall. Anyone who has drawn the free body diagram will tell us 60 newtons. How it can be 60 newton beta? From where you have created 5 newton, 10 newton extra, the force on the wall has to be 50 only. So these are the answers that I was looking for. Some people have sent me. Yashwant has sent me diagram here. Yes, Yashwant, it is correct. So if you have to send your answers on Telegram group data, please don't send me personal message. There are too many personal messages for me to see and I might miss it. If you have to send it, please put it on the group. That is easier so that at one place I can see all. Send it personally, I'll have to open up all. Okay. So These are the answers that I was looking for. I'm loading all hands. Anyone who did not understand, anyone who has any doubt, please raise hands. Sir, I have a doubt here. Sir, I have a doubt there. What I have done? I have not done anything. After doing these many things, the diagram may look a bit awkward. I could have done it in a cleaner way, but I just wanted to tell you, I have just written the equation right below the diagram so that you understand from where I am getting those equations. That is the only reason that I am doing it in the same diagram. Again, I am not drawing the free body diagram separately because I don't want you to do it in the examination hall, because in the examination hall, time is very important. If you take a lot of time in drawing the diagram separately, you will lose a lot of time. That is why I'm trying to do the question in the way that you must be doing it in the examination hall. And this is not the way that you should do it in your notebook. The notebook, you should do it in a fair way. Am I clear to all of you? Can I have raised hand that we understand this, sir? And that we are following what I am saying? Only 5 people understand this. Not good enough. Let me wake everyone who is still sleeping. Manasa is sleeping. Reddy, Yashwant, Dinesh, Rishika, then some numbers. Shreya, Siddharth, Padmakan, Ganesh, Jasmine, Praveen, Kartik, Yashwant, Kevin, Kartik, Shashank, Yogeshwar, Charita, MPC, Pranay, where are you, beta? Rahul, are you all there? Great. Let us move ahead. Lots of work needs to be done. We are surely moving towards perfection. We are going to get perfect. It will take time. Let us move on to the next question. Let me think what should be the next question. Okay. I'll make the question like this. As you can see, one block is kept on an inclined plane, 10 kg mass. The other block is hanging, mass is m, incline is 37 degrees. You have to find out all the unknowns. What are the unknowns here? I think one unknown is m. The other known is tension in the string. I think there's only one string here. The other known will be the normal reaction from the ground end. Are we clear? To find out this, so once we will try with car and car tension. What do you mean by car and car tension? You're talking about elevator? What are you talking about? I don't understand car and car tension. So here is your question. Please follow the steps and get me the answer. Don't worry, we'll do all types of questions that are possible. Trust me on this. When I say that we'll do all questions, we'll do all questions. Don't have to worry. No, I did not understand beta what you were asking. Car tension. I did not understand the meaning of that word. Maybe you were talking about cable car, elevator car, what car? Or you are trying to pull the car. That's why I don't understand. I didn't understand. Anyways, don't worry. We'll do all the problems. Don't worry. We'll do all the relevant problems that are relevant. Anyone got the answer? No one has sent me the answer, so no one has got it probably. Teja has given me the answer for normal reaction is 100. No, it is not 100 beta. Just so you know. Okay, I got it, got it. Chalo. I will do it. Don't send me on my personal message. I will not see it beta. It takes a lot of time for me to open it. If you have to see, send it on the public and on the normal group. Send me on the personal message. It's difficult for me to see it. Okay. So if you have to send anything, send it on the group. Okay. So how do we go about this? We start with the sketch. Sketch is already there. You have to draw free body diagrams. I start with the tension in the string T, 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 and T. This is done. Let me start with the block. 10M, G is taken as 10. This becomes the free body diagram of this block. As soon as I get the free body diagram of this block, let me write the equation for this block so that this block is over. So what is the equation for this block? I will take the y-axis like this. I will take the x-axis like this, horizontal. There is no force on the horizontal, so this is gone. Only thing remains is vertical. So what is the equation for this block? T equates 10M. That is the equation for this block. Do we understand this, everyone? T is equal to 10M. That is the equation for this block. Okay. What next? Let me now move on to this gentleman. Let me draw the free body diagram of this. Weight is 100 newtons. It's going here. Normal reaction will go perpendicular like this. Now, remember, this is not kept on a horizontal floor. So how should I take its axis? I must take this as the x-axis and this as the y-axis. Do we remember this? Yes or no? This axis becomes my x-axis. This axis becomes my x-axis and this axis becomes my y-axis. Yes. Now, as I told you, this weight is going downwards, which is not along x and y. So I dissolve it. I told you to remember this. This is mg sine theta. Mg is 100. Sine of 30. 3 by 5. So this is 100 multiplied by 3 by 5. Do we all understand this, everyone? Can I have raised hands from everyone? This is mg sine 37. Sine 37 is 3 by 5. So downward force becomes 60 newtons. Well done. Then this will be mg cos 37. Cos 37 is 4 by 5. One becomes 60. The other becomes 80. This now becomes the free body diagram of this block. Now, I'm free to write the equation along x and y. What do I see along x? Along x, I see this is 60 newtons and this is T. So what is my equation along x-axis? Along x-axis, my equation is T equates 60. Do we all understand this? This is my equation along x-axis. T equates 60, marked in green for everyone else to see. Well done. That takes me to my favorite axis, which is the y-axis. It's not my favorite. All axes are favorite. On y-axis, what do I see? I see normal reaction n going up. I see 80 newtons going downward. So that is my equation along y-axis. My y-axis equation becomes normal reaction n becomes 80n. If I write 80n, it will look awkward. So I'll just write 80, small n. See, Chetija, you cannot write Newton as small n because Newton is the name of the scientist, sir. So you should write it capital N. So it will create confusion. So I'll just write it as 80. Normal reaction becomes 80. So I've got the value of t, I've got the value of n. What will I do now? I will put this value of t equal to 60 in this equation, and I'll get the value of m. The value of m becomes 6 kg, and these are the answers that I was looking for. These are the answers that I was looking for. Do we understand this? Do we understand this? Can I have raised hands from everyone who have understood this beta? Can I have raised hands from everyone who understood this beta? Only 13 people have understood this. It is not going to be enough for me. So I'll now call your names and ask whether you have understood it or not. Starting from the last one. Manasa, she is sleeping. Reddy, Dinesh, Shashank, I've got some names now. Rishika, Navya. Navya, where are you, beta? You're not responding. Are you able to understand this? Shreya, Siddharth, Satvika, Jasmine, Karthik, Yashwan, Jogeshwar, Charita, Rahul. Great. I think girls are more active than guys. Aishwarya, good. Aishwarya. I think more girls are responding, or all the numbers are responding. That is good. TNK 3007 till 2006, everyone is responding. Wine is already there. Okay, that is good news. So we understand this, how we have to do this. Follow simple steps, and we are done. Nothing to worry about, nothing to be scared of. These are simple things that can be done simply. Now, let me give you one question, and I hope you can give me a satisfactory answer. Whatever number it is. What question should I make? I should make this. Make that. Okay, I should make this. So I am making this question. This is a block of mass 10 kg attached to 3 strings. How many strings you see here? 3, na? String number 1, ting 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 ting. String number 2, ting 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 ting. String number 3, ting 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 ting. And the question is very simple. Find out the 3 unknowns. What are the 3 unknowns here? T1, T2, T3. The time starts now. Are we trying, everyone? How many of you are trying? Santosh, Deepak, Sainath, so many people are trying. Teja has given me answer. Okay. Okay. Let me try this. So how will I try? I will try to draw the free body diagram here. Free body diagram. Let me call this as T1. So this becomes T1. Let me call this as T2. So this becomes T2. Let me call this as T3. So this becomes T3. The one thing that I did not tell you, there are missing informations here. The one thing I did not tell you is this angle. One thing I didn't tell you is this angle. This is T3. T3, T3. One thing I didn't tell you, first thing is this missing angle. No one asked me why this angle is missing. So just let us call this angle as 37 degrees. So this angle was missing. First thing. What else? So what do? I have drawn this. I will now draw the free body diagram of this. This will be 100 Newton. Yes or no? This is 100 Newton. Now, this entire thing becomes a free body diagram. I will choose an inconvenient axis. So this is my y-axis and this is my x-axis. Okay. This is my y-axis. This is my x-axis. Now I am trying to write equation along x-axis. Now let us see what do I see along x-axis. X-axis, T1 I see. But there is one force T3 which is going like this. So I'll have to resolve it. It is not along x-axis. So how do I resolve it? This is T3. This is 37. So this becomes T3 sine of 37. Do we understand this? Sine of 37? No. It has to be T3 cos of 37. Do we understand this, all of us? Yes, beta, correct. So it is 4T3 by 5. So on the x-axis, I have T1 this side, 4T3 by 5 this side. I've written it in red. And the funny thing is, when I put green on it, it becomes black. Life is amazing. Colors are amazing. Okay. Now, if that becomes T3 cos, this becomes T3 sine. Sine is 3 by 5. So this becomes T3 into 3 by 5. Do we understand this? So my x-axis equation becomes T1 is equal to 4T3 by 5. Every one of us understands this? The x-axis equation? Yes. Cannot be solved? I must move on to my y-axis. So y-axis I will write here, y-axis. Now let us see what I have along y-axis. Let me use the yellow one. Above I have T2, 1 T2 and 1 3 by 5 T3. And below I have 100 newtons. So what is my equation? T2 plus 3 by 5 T3 equates 100. This is my equation along y-axis. Do we understand this? Do we understand this? Yes, sir. The question is, how many unknowns I have? How many unknowns I have? Try to understand the unknowns. Yes, Vahini. I have 3 unknowns. T1 is unknown number 1. T2 is unknown number 2. And T3 is unknown number 3. But how many equations I have? I have only two equations. Three unknowns cannot be solved from two equations. That means I have missed something. Here I have not missed because I have not given you the information. But many a times you will come across a condition very soon. You will come across condition where you will feel that you have drawn the diagram correctly, you have marked all the forces correctly. But again, the number of equations, yes, Hanak, it is not 100. But again, the number of equations that you are getting are always less than the number of unknowns. That means you have missed something. And that time you remember this question that, sir, we have missed something. What I have missed here is what I have not told you here. So I should have told you one thing. I must have given you one relation. So let me say that I've given you the relation that T1 is same as T2. If I had given you this relation beforehand, that T1 is equal to T2, now you have three equations and three unknowns, and now you can solve. But if this equation T1 is equal to T2 is not there, you will not be able to solve it. So remember, whenever in this chapter and from here on, you will have this problem in this chapter and in the chapter of rotation. You'll have a lot of problem on this. You'll always have equations, but you will always find yourself short of one equation. And then you have to think, yeah, I'm missing something. How did you get that equation? I'll tell you when time comes. Here, I've given you the equation T1 and T2. You can use this equation and get your answers. Remember one thing. You can only get from one block or from one body. How many equations are possible? From one block or one body, only two equations are possible. Yes, Hannah. What are those two equations? What are those two equations? In this case, one equation along x and the other equation along y. So you count how many bodies you have, how many equations you will get from one block, maximum two. You will say, sir, what about z-axis? Yes, beta, you can get an equation for z-axis, but in the question that you will do, you will hardly have any force acting on z-axis. No force or no point of this equation. So one block will give you maximum two equations. In some cases, it will only give you one equation. See, the block that we had drawn here, this block only gave us one equation, only gave us equation along y. It did not give us any equation along x because there was no force along x. So remember, whenever you solve a question in this chapter or the chapter, look at how many equations you are getting, look at how many equations are possible, look at how many unknowns are there, and then if you are falling short of an equation, you are not able to solve that equation. Do not just get the equation and start solving them. Or sir, it is not getting solved. Think how many unknowns are there and how many equations you have made. So when you look at the number of unknowns and look at the equation, think whether the equations are equal to the unknowns. If yes, you will be able to solve them and you will be able to get your answer. Finally, you cannot make equation along z-axis because there is no force. So along z-axis, any equation you make, 0 is equal to 0. What will you get from that equation? You will get nothing from that. Am I clear to everyone? Whenever you solve a problem, you get equations, look at the number of equations you have got and see, the first thing that you see is how many unknowns are there. Do not just start solving the question because even in this question, you got answers. Some of you got answers, right? That means that you have done the mistake that I was looking for. Or if you have not done the mistake, You were trying to solve and you were not able to solve. That means you have not understood that you have got the less equations and you have more number of unknowns. Would you remember this? When I have raised hand that you understand this, sir? Whenever you solve any problem of this type, you will look at the number of unknowns and the number of equations that you have created. Only 3 people will do it. And the rest of you will be finding problem in solving it. Manasa, Dinesh, Shashank, I hope you've understood this. Navya, Honda, all these roll numbers. Shreya, Siddharth, Satvika, Reddy, Padmakan, Jasmine, Praveen, Karthik, Shashank, Teja, Charita, Arpit, Aishwarya, Venu, Goli. Okay. So that was the understanding from that particular question. Now let me put the question in a different and see if we can solve it now. So what I'm going to do is, I'm again going to hang it. Again going to hang it. Now how many strings you see? How many strings you see? 2. So how many equations are possible? 2. Remember that. Keep that in your mind. So then I write this. So there are 2 strings here. String number 1, string number 2. I have changed the question slightly. Find out the tension in the 2 strings. I hope you can solve it now. Obviously, the mass is an equilibrium. Are you trying the question beta, everyone? Shall I help you out? So how do I solve this one? Pretty simple. I start with the free body diagram. I call this tension as T1. I call this tension as T1. I call this tension as T2. I call this tension as T2. 10M goes here. How does my equation, how does my x and y look like? My y-axis goes like this. My x-axis goes like this. Yes or no, everyone? Do we understand up till this point? Now I have a problem with this. I have a problem with this tension because this tension is going in this direction. So I will resolve it. Oh, I have written it wrongly. Yes, it is not 10M. It will be 100. I thought that I have. So this is 100. Thanks for correcting me. Okay, so I have to resolve this tension. This 2 becomes T2 cos of 37. Cos of 37 is 4 by 5. this force becomes T2 sine of 37. So that is 3 by 5. Do we all agree on this? Well done. Now I'm writing equation along x-axis. Look at what is there along x-axis. My yellow thing is along x-axis. 50 Newton is towards left. 4 T2 by 5 is towards right. So my equation becomes 50 equals 4 T2 by 5. Yes, so I can get the value of T2. I hope you can get the value of T2 from here. What about y-axis? What about y-axis? What about y-axis? Green thing is my y-axis. I have T1 up. I have 3 T2 by 5 up. And I have 100 down. Who is going to tell me the equation along y-axis? The equation along y-axis is T1 plus 3 by 5 T2 is equal to 100. This is my equation along y-axis. Do we understand this? I already know the value of T2. I can put the value of T2 here. From where? From where? From here, tick, 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 tick. T2 comes, goes here, and I get the value of T1 as well as T2. Do we all understand this? Can I have raised hands from every one of you that we have understood this? We will look at the number of equations, only 2 equations, 2 variables. We should be able to solve them. Then you look at solving them. Do not just start solving as soon as you get equations, because you might end up, Teja, well done. You might end up with a condition where you have less equations, more variables, and you are still keeping on solving them. You will not be able to get their values. So on that note, on that lesson, I will dismiss the class today. Tomorrow is your test. The syllabus is motion in 2D and relative motion. Try the test out. Take it as a step for your final exam. If you get good marks, well done. Keep on improving. If you don't get so good marks, no problem. It is just a small test. You can always improve. I always feel that if you don't get good marks, that is always a good sign, because then you have the urge to improve, the passion to improve. On that note, I will call it off a day. Take care, and I will see you soon. I think on Tuesday or Monday, whatever your class is. Till then, stay safe, stay happy, and stay blessed. Take care. Thanks, beta. Thank you, Anna. Thank you, Vaini.